Hello dear grade 11 students. In these videos we are going to enjoy limits at a point, and we are going to talk a little bit about limits at infinity by a fast way. Now here we start with the first example about the limit at a point. I want to determine the limit of this as x approaches 1. So what should we do? Let's start. First of all, I have to evaluate 1 in place of x. Then I'm going to get 1 minus 1 in the numerator and 1 minus 1 in the denominator. And that's 0 over 0, which is the indeterminate form. So this is an indeterminate form, so we start thinking of solutions to get rid of the indeterminate form. So we have to find limit as x tends to 1 of x squared minus 1 over radical x minus 1, and we multiply by the conjugate. The conjugate of radical x minus 1 is not radical x plus 1, it is radical x minus 1 itself. And here is how to make this clear. If I have 1 over radical x minus 1, then its conjugate that we multiply by is radical x plus 1, and we surely have to multiply by the conjugate up and down, because multiplying by conjugate is not changing the value, it's just changing its shape, okay, its appearance. Then when we have this, we have to multiply, we change the sign in the middle. But here, as you notice, the radical is all over x minus 1. That's why we multiply by the radical itself up and down, because it's in reality 1. We are just changing its appearance and making things easier and getting rid of the indeterminate form to get the limit. Now x squared minus 1 times radical x minus 1 over radical x minus 1 times radical x minus 1. Now this will give x minus 1 directly, and x squared minus 1 can be split into x minus 1 and x plus 1. We can factorize it. Now x minus 1 will cancel x minus 1, and what remains is x plus 1 into radical x minus 1. Finally, we evaluate, we remove the word limit, and we substitute 1 plus 1. We replace x by 1 as required because x approaches 1, into radical 1 minus 1, so we get 2 into 0, which is 0. So the limit of x squared over radical x minus 1 as x approaches 1 is 0, and thus we name it 1, 0 is called the limiting point, or is called a limiting point. What do we have in the other example? Okay, we have to find the limit as x goes to 2 or approaches 2 or tends to 2 of x squared minus 4 over x squared minus x and minus 2. Now as you see, if we substitute 2 in place of x, we are going to get 4 minus 4, which is 0. And if we replace x by 2 in the denominator also, we are going to get 2 minus 2, which is 0. And that says that's a clue that 2 is a root for the numerator and it is a root for the denominator. That's why we are getting 0 over 0, which is the indeterminate form. So we have to fix this, fix it. We have to get rid of the indeterminate form, so we have to factorize. X squared minus 4 is definitely x minus 2 into x plus 2, and x squared minus x minus 2 is, using the calculator, it is, so when we use the calculator, we choose 5, then we choose the quadratic form 3, then it is 1 for A, minus 1 for B, and minus 2 for C. Then the roots are 2 and minus 1. So the roots of this one are 2 and minus 1. Thus, the factors are x minus 2 and x plus 1. So to factorize x squared minus x minus 2 after finding its roots, we write, if the root is 2, then the factor is x minus 2. If the root is minus 1, then the factor is x plus 1. And by this, we factorize the denominator and the numerator. Now, x minus 2 and x minus 2 are going to be cancelled. Then what remains is x plus 2 over x plus 1. And now we get rid of those making zeros. Thus, we just evaluate 2 in place of x. Then we get 4. 2 plus 2 is 4. And 2 plus 1 is 3. And thus, the limit as x goes to 2 is the constant 4 over 3. Now, what about the limit as x approaches minus 1 of the same function? Okay, so as x approaches minus 1, note what's written here. The roots of the denominator are the values we care about. Okay, notice that x tends to 2 and x tends to minus 1, where minus 1 and 2 are the roots of the denominator. Those are the numbers that we study the limit at. They are the roots of the denominator that make it 0. Now, what about x going to minus 1? Here is the table that helps us to complete the question and to find the limit. Why do we use this table? Let's go ahead. When we evaluate in the numerator, when we substitute x by minus 1, we get 1 minus 4, which is minus 3, which is not 0. So definitely we are not going to get 0 over 0. Whenever we don't get an indeterminate form, we start studying the limit at the value minus, as you see here, at minus 1 minus, and at the value, the same value, which is minus 1 plus. That means I'm studying the limit. If we have a number line here, okay, and here is minus 1. Minus 1 minus means approaching minus 1 from the left, and minus 1 plus means when approaching minus 1 from the right. So I use the sign table. Here are the roots, minus 1 and 2. And here we use the idea of same, opposite, same based on the sign of A, which is 1, which is positive. A is positive. So the same sign of A between the roots, the opposite sign of A, which is minus, and here the same sign of A, which is plus. So we use this table in order to help us know the sign of the 0 we are putting down. 0 plus or 0 minus. Definitely in the denominator we will get 0. Why? Because we are studying the limit as x approaches one of the roots of the denominator. Okay, so again, whenever we get 0 over 0, the indeterminate form, we have to think of factorization in order to cancel those giving zeros. Whenever we have to do this, and the answer, whether constant or whatever, is the limit. Now, if we don't get 0 over 0, we have to study the limit at the value minus and at the value plus, when we approach it from the left and when we approach it from the right. That's what we mean by minus 1 minus, means approaching it from the left. So here is minus 1 minus, and minus 1 plus means approaching it from the right. Okay, so we didn't do that for 2 because it gives an indeterminate form and we get rid of it by factorization. Okay, now limit as x tends to minus 1 minus of x squared minus 4 over this, we just put minus 1 in place of x, we get minus 3, and directly in the denominator we put 0. 0 plus or 0 minus is based on the table. So because we are talking about minus 1 minus, so that side here, then that side has a positive sign, so we put 0 plus. Again, directly we put 0 because minus 1 is a 0, is a root for this, and we put 0 plus because this sign here is plus. Then minus 3 over 0 plus is minus infinity. Minus over plus is minus, and 3 over 0 is approaching infinity. Again, for minus 1 plus. For minus 1 plus, we are approaching minus 1 from this side, from the right, then we are in the negative region. Okay, so we directly substitute. Minus 1 squared is 1, minus 4 it is minus 3, but because we are in this region, then we have to put 0 minus. Again, we directly put 0 for the denominator because minus 1 is a root for the denominator. That makes it 0. and thus we put 0 minus because here we have a minus sign. Now minus divided by minus is plus infinity. Okay, so minus divided by minus is plus, and 3 divided by 0, something approaching 0, is plus infinity. What do we mean by 0 minus and 0 plus? 0 minus is a number. If we have here 0 on the number line, 0 minus means approaching 0 from the left. So we are talking about a negative number. That's why when we divide minus 3 by 0 minus, which is a negative number, we get plus infinity. What do we mean by 0 plus? 0 plus is approaching 0 from the right. Here is 0 plus. So we are talking about, it's about, for example, 0.0002, whatever. So we are approaching 0, but from the right, then we are talking about a positive number, and that's why minus by plus is minus. Okay? Now, after doing so, we can say that x equals minus 1 is a vertical asymptote because the limit as x approaches minus 1 of this function is infinity, whether negative or positive, never mind, but just saying that the limit as x approaches minus 1 is infinity, we say that the line x equals minus 1 is a vertical asymptote. Now, where did the horizontal asymptote come from? Let's look here. If we have to find the limit as x approaches infinity, usually horizontal asymptotes come from studying the limit at infinity of x squared minus 4 over x squared minus x and minus 2. We usually, as you know, take the highest power from the numerator over the highest power from the denominator. When we simplify them, the answer is 1. That's how to deal with limits at infinity. We can take the highest power from the numerator with the highest power or over the highest power from the denominator, and the answer is here 1. For example, if we have 2 here over 3, so the limit will be 2 over 3 at infinity, and thus we say that y equals 2 over 3 is a horizontal asymptote. So if x approaches a number and the limit is infinity, we say that this number, x equals this number, is a vertical asymptote. If x approaches infinity and we get a number, we say that y equals this number we get is a horizontal asymptote. Now, what do we call that point? 2 of abscissa 2 and ordinate 4 over 3. We call it the limiting point. It is 2 as abscissa and 4 over 3 as ordinate.